Ja, herzlich willkommen zum Cloud Native Meetup Bern. We will make a short introduction in German or in Swiss German, and then we will proceed in English. The talks will be in English, so stay with us, English-speaking friends. Okay. Our topic is Keptn and Citadel. And before I will start with the agenda, I would just erzähle ich euch etwas über das Setup, das wir haben. Das ist eigentlich immer das Gleiche. Also wir sind alle zusammen mit den Speakers zusammen so ist in einem Zoom-Setup. Meeting und das wird über OBS, wird das auf YouTube gestreamt, wo ihr seid und wo ihr auch könnt eure Fragen stellen im Chat. Und wenn wir von einem Speaker zum nächsten wechseln, gibt es aber kurzen Wechsel von maximal 60 Sekunden. Es gibt so einen Countdown, der läuft und dann seht ihr dann, wenn der nächste kommt. Wir haben heute 2 Talks. Genau, das haben wir gesagt. Fragen bitte YouTube-Chat. Das kommt dann zu uns mit einem ganz kleinen Delay halt. Oh, shoot. Da muss ich etwas eigentlich zeigen. Das ist der Beste. Ja, der hat gar nichts gesehen von meinen super Folien. Ich hoffe... Total falsch drin. So, jetzt kommt es gut. Jetzt hätte ich noch die Folie. Dann schnell zurück zu dem. Das ist, ja, das, wenn ihr alle im Meetup-Seite kennt, ihr das schon. Das ist echt das, was ich gesagt habe. Wenn ihr eine Frage stellt, dann kommt es in YouTube-Chat und wird dann von uns aufgenommen im Zoom-Meeting. Wenn ich von uns rede, dann ist es ein ziemlich grosses Komitee da, Organisationsteam. Eigentlich, wir sind organisiert als Verein, Berner IT Rocks. Und wir durchführen eben regelmässig die Meetups durchführen. Wir sind aus verschiedensten Berner Firmen, ja, und organisieren das für euch. Ihr erreicht uns am einfachsten via Twitter mit dem Handle da, @Cloud Native Bärn. Genau. Oder auch über den Hashtag hier. Unsere Mission und Vision, das ist eigentlich eben von Engineers für Engineers, eben für euch. Und Get Your Hands Dirty, das habe ich schon gesehen im Vorfeld, dass das heute gemacht wird. Wir sehen auch ein bisschen Konsolen-Hacking heute. Und eben aus der Region, für die Region, zumindest ein Speaker ist aus Bern. Genau. Und dann noch kurz in eigener Sache, dass wir das alles organisieren können, sind wir auch immer wieder auf Hilfe angewiesen, auf Sponsoring angewiesen. Und wenn du jetzt hier drin bist und das gerne auch würdest mal unterstützen, dann ja, steht hier alles drüber, komm auf uns zu. Und wir sind sehr happy, dass wir eben einen Sponsor haben für die Durchführung. Das ist Dynatrace. Merci vielmals an Dynatrace für den Support von diesem Meetup. Und dann sind wir schon bei der Agenda. Ich bin jetzt schon durch. Wir haben den ersten Talk mit dem Robin Wyss. Das ist eben, beide Talks sind auf Englisch, wie schon gesagt, wo Keptn wird vorstellen. Und der zweite Talk mit unserem Gast aus St. Gallen, wo Citadel wird vorstellen. Und dann, was ich ganz vergessen habe, ist noch der Icebreaker ganz am Anfang. Und bevor ich sage, das nächste Meetup ist am 18. März, kann ich noch schnell schauen, was ihr findet, was der latest, genau. Was ist für dich im Moment, das haben wir ja gefragt am Anfang, was ist für dich im Moment latest and greatest? Conventional Commits, Kubernetes, Customize, Serverless, Hugo, OBS. OBS habe ich schon vorhin gemerkt, das kommt vor allem von den Leuten hier. Und dann haben wir auch noch fragen, was würdet ihr gerne beim nächsten Meetup sehen? Da gehe ich jetzt nicht durch, wir werden es aufnehmen und anschauen, wenn wir das nächste Meetup zusammenstellen. Wir haben dort noch freie Slots. Dann würde ich jetzt in diesem Fall die Übergabe machen an Robin.
Hello and welcome. My name is Robin. I'm from Dynatrace, and today I'll talk a bit about a project called Keptn, which is an open source project, and the topic is automating SLI and SLO-based build validation with Keptn. So we'll see how we can use Keptn to automate SLI and SLO build validation. You can find Keptn on the internet. As I mentioned, it's an open source project. So there's a website, Twitter, and all of the important information, how to communicate, like GitHub or Slack. And I'll show those links again at the end. All right, so let's get started. What do we mean by build automation? So typically in a CI/CD process, there's you try to automate as much as possible. You have automated builds, automated deploys, you will run tests automatically, but there's often, at least what we see with this often is you have a manual process in between somewhere, whether it's to evaluate the tests, evaluate the performance tests, or do some tasks in between, which slows down your build and makes that manual step required. So what it could be is that you have functional tests and then you get a test results. And in general, on functional tests, it's usually pretty clear, right? The tests pass, so it's fine. Then you can move on in your CI/CD pipeline. If they fail, typically you would stop, but there might be issues where, or cases where you can say, well, most of it went through. There's maybe some functionality that's, I don't know, let's say a warning. So somebody could decide to move forward. But most often we see the topic in performance. So when you release a new version of your product, you want to make sure it's performing well and it's not performing worse than before. And for that, you do performance tests. So you run tests, measure response times, and then you need to decide, do we move forward or not? And this in most cases is a manual step that you do. So you can automate a performance test using JMeter, Neoload, whatever you use. But in many cases, you will have somebody look at the tests and see, is it performing good? Or another example is the error rates. Are there many errors in the requests? If there's too many, then of course you want to halt the build. If there's maybe only a few, that might be okay. And then you will also throw in monitoring to the mix, maybe. So here's an example, Prometheus and Dynatrace, so the two monitoring solutions that are supported by Keptn. And then you will evaluate based on the monitoring data and decide whether this build should go forward and be moved to production, for example, or if there are some issues that you have discovered in monitoring and stop the build. And this is a step that we would like to automate because, of course, automation is great. I'm pretty sure most of you would agree. It gives you more time for something else. Whatever you do with that time, I'll leave that up to you. But I think the other thing that this little conversation shows, so I don't remember actually where I found this, somewhere on the internet, but it also shows that it's not always easy to automate, right? You might write some automation script, it works once, but you need to maintain it, and more often than not, it will break at some point. And this is kind of what what is the reason what brought Dynatrace to develop Keptn. So if you look at, this is just some information from a report that was created by Puppet. So it's called the State of DevOps report. It's a 2020 report. And what makes companies and teams successful is to have a continuous progressive delivery pipeline, right? To automate a lot of things in there, use the tools needed, whether it's in private infrastructure or use the cloud tools available, and then integrate everything with development environments, set up monitoring and alerting in order to have a quick feedback loop, and also audit log, see what was changed, who changed it, and when. So that's what people, based on the survey, said that's what helps them. But the challenges here are typically the time. It's time consuming to set this up. There's a lack of standardization, and it requires a lot of technical skills. Often delivery pipelines involve a lot of code, are written very specifically. It's a mix of different subjects, and that's a big challenge. And Keptn actually aims to solve exactly these issues. So have a standardization, require less technical skills, and make things faster to set up. And we can also see that most of the people say that there are a lot of the self-service tools were actually built internally. So companies and teams built their own platforms for the delivery pipelines. And that's kind of what brought Dynatrace to deliver Keptn, to build Keptn. So Keptn is it's now an open source project. It's part of the Cloud Native Foundation. But it was created initially internally at Dynatrace. And here just an example of a build pipeline. So this is a real build pipeline that was used at Dynatrace. And there's a lot of information in this code, a lot of mixed information about the process. So there's some code to build the application. There's a lot of code to deploy. It targets different platforms, whether it's Kubernetes or rather just Java server, whatever you use. It also speaks directly to the different environments, development, hardening, staging, production. And it involves also a lot of tools, right? Terraform to set up your infrastructure, Helm to deploy, etc. And there's also no clear separation of concerns. So there's code that is meant for developers. There's code that more talk to the DevOps aspect of things or the site reliability engineers. And typically you build one pipeline and then for a service, then comes another service. So you copy the pipeline and then you make some changes and then you have another service and copy again. And this really leads to like a sprawl of pipeline code that is being reused, and it's hard to make a change in the original one and then propagate it down to the other pipeline. So it's really cumbersome to maintain. And Keptn was designed to address these challenges. So it's if you go to the website where Keptn says it's an event-based control plane for continuous delivery and automated operations. So that's kind of a lot of buzzwords in one sentence, but really what it provides is a control plane where you can set up your build pipeline in a declarative way, and then it integrates through an event-based mechanism different services. So it could be services for maintaining the configuration, deployment services. So having all these different services spread out and communicate through events. It uses Cloud Native events, so a standard way of providing events, and it's also developed in an API-first approach. And as I mentioned, it's part of the Cloud Native Computing Foundation, so it's a product that's under that umbrella. And so if you go a little bit more into detail, so how Keptn works. So there's different use cases that you can use in Keptn. It could be SLO-based quality gates and progressive delivery. So that's kind of what we look into today. And then there's SRE, so site reliability engineers automation and auto remediation. I guess it's probably one step further where you can have more to move towards autonomous cloud or no-ops aspects where you can remediate in when there's an issue, trigger some actions to remediate the problem. You set up the Keptn using some configuration. So we'll have a shipyard file, but we'll have a look at that in a second. Then you define your SLI and SLOs in a configuration, and you might have additional configuration like runbooks, workloads that you then store in Keptn. And most importantly, it's not a new tool for doing continuous integration or continuous delivery. It's really a control plane that helps you connect the tools you already have, whether it's Jenkins, Argo CD. But it's built on top of Kubernetes, so it runs in Kubernetes, supports Prometheus, JMeter, and there's more. I'll show a little bit more of the tools that are supported later in the talk. And Keptn allows you, thanks to this, to automate this process a lot. So you automate monitoring. So you can actually, with Keptn, automatically create monitoring, for example, dashboards, etc. And you can automate the delivery approach. So how you deliver software through the pipeline. It provides additional reliability and remediation, and as I mentioned before, with the auto remediation functionality. And it does this through an event-driven approach. It's declarative, so you don't code your pipeline. So it's you set it up in a declarative way. It uses GitOps, so all your configuration are typically stored in a GitHub repository or any Git repository. And it uses standards and concepts from the SRE world, like SLIs and SLO, which we'll go into more details. So this was kind of an introduction for you to set the scene. What is Keptn? So now let's see how do we build an automated SLO-driven delivery pipeline. So when you start with Keptn, first thing you need to do is you will define a shipyard file that defines the different stages. We'll have a look at more details on the shipyard file in a second. Then you can define in another configuration an SLO, so your service level objectives. And then you also need something to deploy your services. It can be through Helm charts, which is the standard way in how Keptn does it. But you could also have the deployment being triggered by, for example, Jenkins or Argo CD or any other tool. So when you create, or when you get started with Keptn, the first thing you typically do is you create a project. So that's kind of the top level kind of concept in a Keptn. So you have a project, and the project has then different, for example, services that belong to that project. And when you create a project, you define a shipyard file. So you can see where the terminology comes from a little bit. So Keptn shipyard, so of course it's a little bit leaning towards the boating environment. But in the shipyard file, you define your stages. So for example, you can see my mouse. You have, for example, a development environment. So that's a stage here. You define deployment strategy. Direct means that it will be directly deployed to that environment. And you can set up, for example, test strategy. In this case, in the development stage, we do a functional test. Then in the staging environment, there's also an approval strategy, meaning that based on the tests in development, how do we approve to go to the next step? And in this scenario, we have, when the tests pass, it's going to be deployed automatically to staging. If there's a warning, it's also going to be automatic. And then we have a deployment strategy, meaning blue-green. So it will deploy canary, run the tests on the canary before deploying the primary service. And the test strategy here is performance. So on staging, we'll run performance tests. And then the next stage, production. Again, we have an approval strategy. Here you can see it changed a little bit. So if the performance tests are all good, then it's approved automatically. If there's a warning, then it needs to be approved manually. And again, the deployment strategy is blue-green, and the remediation strategy. So I'll not show that in the example, but I'll talk a little bit about it. But if there's remediation, so it should apply auto remediation if that has been set up. And this is how it looks like in what's called the Keptn bridge. So in the UI provided by Keptn, so we see the stages: development, staging, and production. Next thing that you would do in Keptn is add services. So this is based on an example called Sock Shop. So that's the product we created before. And then you onboard services. So here's a service called Carts in the project Sock Shop. And with the chart, we specify a Helm chart. You could also, if you use something else to deploy, then you would not onboard, and you would create the service, and the deployment would be done by an external tool like Jenkins. And here that it's just one command, but for the project, it was actually onboarding 2 services. So in the sample I'll show later, we'll see there's a cards service and a cards database service. And then just to have mentioned it, so there's additional files that we can add. For example, when we run the tests, we run them using JMeter. So there's a JMeter service that comes with Keptn, and we can specify GMX files. For example, one is called basic check, which runs the functional tests. And then there's a load GMX, which runs the performance tests. And those are added as resources in the Keptn project. And then the JMeter service automatically checks in that JMeter folder for resources for running the tests, for functional and performance tests. And then, so that's basically all you need to set up Keptn, an initial pipeline, and then you can actually trigger an event because everything is event-based. And here the event says there's a new artifact that should be deployed. Again, we specify the project, which service, and then an image. This image now is from Docker Hub, so it will deploy a new version of that service based on that Docker Hub image and tag it with a version. Then what happens is, as we saw, it will deploy to dev. Deployment strategy is automatic, so it will just deploy that service to the development environment and override the previous service, then run some functional tests. Then it will evaluate the tests, whether it was good or not. If the tests were good, it will move forward to the next stage where we have a canary deployment, run again some tests, evaluate the tests, then deploy the staging because we use a canary approach. So that happens at the end if the tests are good. Otherwise, it would not do that step. And then it goes to the production environment and deploys to production, again with a canary and then and a deployment. And of course, we don't run any tests in the production system. So that's what end users are for, right? So at this point, I'll switch quickly over to my command line to show you how that looks like. Let me just quickly clear. So I have a Kubernetes environment. I'll just show kubectl namespaces. What unknown command is for? Yeah, okay, then I need to write it correctly, get namespaces. So this is my Kubernetes environment where I have several namespaces. We see the standard ones from Kubernetes. So we have a Keptn namespace, so that's where the Keptn services run. And then the other interesting part is the sock shop, which is the example that I'm using. So there's 3 namespaces, 1 for each stage. So if we look at the pods in the Kubernetes namespace, for example, just so that you can see how that looks like, there's a number of pods. And most of them are used internally by Kubernetes. So there's an API gateway service bridge, which represents UI. There's, of course, an event broker. And then there's some services that can be added. For example, the JMeter service, the Helm service. So Helm service to deploy the services, JMeter to run the tests. But it could be, for example, that you have neoload. So you would replace the JMeter service with a neoload service. And here already onboarded, but I'll show it in a second how that works. But we see the Prometheus service and also the Prometheus SLI service that actually does the SLI SLOM evaluation part. And if I can switch to the UI, and this is how it looks in the UI. So the Keptn provides a user interface where you can see the projects. Right now we only have one, this sock shop. It also stores the configuration, so in that GitOps approach in GitHub. And if I click here, it will go to that repository where it created that shipyard file. So no surprises here, that's the one I have provided. And then we have different branches, one for each stage. So if we go to the development, interesting. Oh yeah, because I'm on the shipyard, sorry. So if I go to the development branch, I can see the card service and the cards DB service. So these are all the configurations needed to deploy. If I go to the cards, you will also see the JMeter file that was added for the basic check. So it's a JMeter file that will run the JMeter tests. now before going back, I'll start a new deployment because this will take a while. I'll start it now and hopefully it will be done by the end of my presentation because this will run some performance tests, which take a while. So I sent the event that I've shown before in my presentation. So a new artifact for the sock shop, for the carts service, an image, and then we have a specific version, which is 11.2. So this is a new version of my sock shop. And we'll let that run in the background, and I'll get back to my slides. So now as a next step, and in my example, I've already done that, so, but I'll show how that works. You want to add monitoring because that is required to evaluate your SLIs and SLO. In this scenario, using Prometheus monitoring, so setting up the Prometheus services is just apply this deployment description here, this is service YAML, and then configure the monitoring for the cart service. We'll add the targets for the cart service, and we see in the different environments for dev, production. Further down would be the staging environment, and that's it. That's all you need to do to add the Prometheus service, and then we can define our SLOs and SLIs. And I've been throwing around these terms a little bit. I don't know if everybody is familiar with the concept of SLO and SLAs and SLIs, but it's basically a term coming from, or at least made popular by Google's SRE practices. I don't know if they have invented it, but at least if you look at the Google SRE handbook, they're using those heavily in their systems. So you have the three concepts. The first one, which is service level indicators. So those are measurable metrics, right? So you can measure an error rate, login requests, response time. So whatever you can measure, typically by your monitoring environment. So this would be an SLI. It's just a pure measurement. Then in the next step, you would add a service level objective. So that means you have now measured, for example, a response time. Well, you want to define what is the objective for the response time or for the error rate. So there should not be more than 2% of error rates in all the requests, for example, or response time should be lower than 1 second. And then the last one, which probably most people are familiar with, is the service level agreement. And this is more like a business agreement or a contract that you set up. So if you go to your cloud provider or any hosting provider, you will see an SLA, which says there's 99.9% uptime, or probably a little bit more nines at the end if it's a good provider. So this is really what you then offer to your customers. For example, if you have a service that you offer to customers, might be internal customers, right? Your internal business would say, well, we need this uptime. So typically the SLO is a little bit higher than the SLA. So you say, for example, we want to have 2% error rate as an SLO. Then you put in a little margin, right? The SLA is a little bit more spectrum, because otherwise it doesn't make sense to have SLOs that are lower than what you have as a business agreement. So the way it works, I guess this is a good summary of it. So SLIs drive SLOs. So based on the measurements you've made, you can define what are your objectives. And then SLOs inform SLAs. So based on the objectives that you have, you can define what is the acceptable agreements that we can put up that we are likely to hold. And there's also, I'll just put a link here, a good video on YouTube for the SRE practices from Google. And how does it work in Keptn? So as a first step, as we saw, you define SLIs. And this is done through a file called sli.yaml, where you have your service level indicators. So there's, for example, an error rate, database calls count, or a response time. For example, 95% of the what is the average response time for 95% of the requests? And this is what is being measured. What you see here is actually the prompt QL, so the Prometheus query to fetch these measurements from Prometheus, because we use Prometheus as a monitoring environment. If it was a different monitoring environment, then this would be specific to that environment. Then the second file would be the SLO, where you define your objective. So you have the, for example, taking the SLI of response time P95, so means that the average of the 95% of the requests. And then you can define what is the criteria for him to pass. So you want, for example, here that the response times need to be below 600 milliseconds. And you can also define relative targets. So meaning it should, if you deploy a new version of your service, you don't want it to be slower, or at least not much slower than the previous one. So this one gives it the range of 10% that it can go over what was the previous recorded response times for the previous version of the service. And then you can also have a warning. We saw that in the shipyard file. You have a pass in the warning setting. So in the warning, you define maybe a higher level, and then that's maybe you could then in some cases decide, okay, we go forward with the warning, so it's maybe not that hard as a score. And then you can weigh it. So if you have a lot of different SLI objectives, so you can put a different weight, and then you have a total score, and then you define what is a passing score, what is a warning score. And all of these SLIs get evaluated. So when you start an evaluation with a Keptn start evaluation, or it's done automatically when you deploy a new version of the service. And then Keptn will actually query the monitoring environment. So in this case, it will be Prometheus and see, okay, what is the average response times for the 95% of the requests? We'll provide an answer, and then there's a score. So if it's a pass as defined in the criteria, it's 1. If it's warning, it's 0.5. Or if, for example, here we could imagine it's the error rate that we set to 2%. It's way too high, so this is a 0. Then it gives you a total score, which then decides, is this build good, should it pass, or is this build not good, should it fail? And then Keptn will do the evaluation, and we'll provide you a score. And then if it's fine, it'll move it to the next stage. If not, it will stop here. And now let me switch back to my Keptn instance. Now we can see if my build actually went through. So if I look at my services, these are the 2 services, cards and cards.db. And I've run a couple of builds before. So this is the latest one. So I started maybe a bit late, so it's still running. But let's take one of the previous ones. It will be the same. So it will. So here you can see all the events that are triggered based on your pipeline. So it will trigger. There's a new configuration. On the development environment, it will directly deploy it. Then it runs some tests. Here we see it run the functional tests from the JMeter service. Then it will retrieve the results and do an evaluation. So here we haven't, for the functional tests, we didn't specify any SLI or any evaluation. So it's always going to be green. Then moving on. Okay, that's fine. It's green. We promote it to the next stage. Here there's an approval. It was set to automatic, so you can see it's automatically immediately approved. And then it will notify a configuration change. Basically now it's the same story. We'll run some tests, and in the staging we'll run the performance tests, do an evaluation, and here you can see the history actually. So we're now at this build. So this is the history, and in this scenario it failed. We see down here on the SLI, it says it's over 1.4 seconds, so it's way above, score of 0, and it failed. We only have 1 SLI, so if there were more SLIs, it would show up here, and at the top the total score, and that means it ends here, so it's not going to move that build to production and roll it back in the staging environment. Move maybe a little bit faster now. I'll want to be mindful of time. I think I'm almost at a half an hour, but just as a teaser. So this was how you would set up an SLI, SLO-based build pipeline. As a next step, you could imagine something like auto remediation. So what does that mean? So when your monitoring environment triggers a problem, so it discovered maybe a response time degradation, will raise an issue, say, okay, there's something going on. Report that to Keptn, and Keptn will look at what do we have as remediation options. And here we see an example of a remediation. So depending on the problem type, in this scenario, response time degradation, there are different steps that could be taken. So first step would be scaling replica sets by 1. So we'll scale an initial replica set and increment the value of the replica. So it's probably not the best example, because there's probably other ways to auto scaling your services. But in the next stage, maybe if that doesn't work, so it will reevaluate the objective. If the response time didn't improve, it'll move to the second step. And here, for example, we have a toggle feature. So it means if you use something like feature toggles in your product, it means you could switch or toggle on maybe an experimental feature that you enabled based on a campaign. That can be disabled, and then we have the auto remediation takes place. So it removes that feature. Maybe that feature was not good, and then hopefully it will resolve the problem. So that's kind of, I would say, the next step, where you really can move towards the direction of having a no-ops approach. So or what else also sometimes referred to autonomous cloud enablement, where you have as much as possible automated, and it doesn't have to wake you up in the middle of the night if because of a new feature something slowed down the response times. And just as a summary, so what we did today, so I showed the pipeline in the beginning. So this pipeline has now been automated, so there's no manual step in between. We have, thanks to Keptn and Prometheus, the JMeter tests that are run, the SLOs that are read from Prometheus to get the measurements of response times or other values, do an evaluation, and then make sure that the results are good, and publish to production if everything is green. And here's an example of an SLO evaluation that has a little bit of more of the SLI that were measured. All right, so this is a wrap up. I think I'll stop here. I had just a couple more slides. This was a summary again, and this is just how Keptn works conceptually. Some more details, maybe just to mention that there's more services than the ones I've talked about today. So for example, we have also integration to Slack that can be done from Keptn, so that you get notifications on Slack. And here, again, some of the tools that are already integrated, Argo CD, Helm, Jenkins, Azure DevOps, some JMeter, so the known testing frameworks, load testing frameworks, some monitoring and collaboration. But of course, this can be extended. It's an open source project. It's hosted on GitHub. And if you have something else, you can write your own service that could be integrated to Keptn. All right, thanks for your time and listen to the presentation. Now, of course, if you have questions, I would be happy to answer them. I hope we're still good on times to have a couple of questions. Just before we go to that, if you want to reach out to me, you can find me on LinkedIn or on Twitter. And again, I've put in the links if you're interested in having a look at Keptn. But now, I know if there were questions in the chat.
Merci vielmals, Robin. Ich glaube, es hat Fragen im Chat. Darf ich weitergeben, Johann?
Yeah, thanks, Philipp. I will ask them in English because we had the talk in English. So there are like 3 questions. You still have the opportunity to write them in the chat, in the YouTube chat, if there are more questions. I will start with the last one. It's about, do you have to use branches for the different environments, or is it also possible to use different Git repos?
Good question. I think by default, it will use branches. I haven't seen an option to change that, but that's a good question. At least that's, so I didn't really mention that, I think, in the presentation, but when you set up the project, you actually specify a Git user, a Git repository, and then you have to specify a Git token. So that's how Keptn will store things in that Git repository. And actually, so you don't have to, basically, it will also store it internally, but of course it's recommended that you store it in your own repository. But a very good question, but I'm afraid that I don't know. I've always used it with one repository up to now, with branches, but it would be a good question to go into the Slack chat. So if you're using chat, there's a Slack channel for Keptn where there's very helpful people that can answer that kind of question.
Okay, thank you. There's another question about the environments. Can those be other things than Kubernetes?
For now, I mean, yes, actually they can be. So then you would not use the built-in release mechanisms from Keptn. So what I showed in the example, it was deploying through a Helm chart in Kubernetes, and Keptn itself runs in Kubernetes. But you can imagine that you trigger a Jenkins, for example, or another tool that will deploy the application, and then you're free to use whatever you have. So if you have already the deployment configured in Jenkins, you just keep that, and then you can use Keptn and connect to it through the events.
Okay, thanks. And there's another question about environments. Can they be on different Kubernetes clusters?
Yes, they can, coming in next version. So that's a very good question. Also one I had myself and asked to the Keptn's Slack. So today it deploys in those different namespaces in Keptn. That's the standard way. Again, you can do it today by triggering another deployment like in Jenkins, and not through the Keptn built-in mechanisms through Helm chart. But in the next version, which I think is 0.8, there will be support to from Keptn directly deploy into different Kubernetes environments.
Okay, great, thanks. I also have a question. In the beginning, you showed a pipeline file which was like 350 lines. By how many lines were you able to reduce it?
Well, that's I don't know what the lines look like now. It's a bit different, right? Because now you don't write kind of pipeline code. So basically, there's 0 lines of code because it all goes through Keptn. So it's configuration actually. It's more defined in the configuration file. So you have a shipyard file and other files. So of course you could argue there's still code, at least in the configuration, and there might be some services that have been written. So I don't know exactly, but for sure we were able to eliminate those 350 lines of code. And I think what even more importantly than the lines of code, I think is just to be able to separate things out, right? Not have like one big chunk, but having different, using kind of a microservice approach also to your pipeline, where you have different services. You have a JMeter service, where you have a Prometheus service, for example, and having different configurations so you don't mix things, and it makes it much easier. For example, if you change from JMeter to Neoload, for example, it's going to be much easier if you have these separate out in separate configurations instead of one big pipeline file.
Okay, thanks. Philipp, ich übergebe wieder dir.
Merci vielmals euch beiden. Robin, kannst du noch schnell die Toblerone zeigen, weil wir ja dir nicht das Geschenk direkt überweisen können, aber das ist so ehrlich die virtuelle Applaus, und merci vielmals für den Einsatz für unsere Community. Merci vielmals.
Ja, merci fürs Organisieren und merci für die Leute, die dabei sind online. Und ja, aber if there's any more questions, feel free to reach out to me to the links or the contact information I've provided. Merci.
Merci auch, dann wäre jetzt wäre kurz der Countdown, der kommt, und nach dem Countdown wird eigentlich anfangen mit dem Florian, der über Identity Access Management redet und vor allem über das Projekt Citadel.
Well, hello, my name is Florian. I'm from Chaos and I'm talking about Citadel. And first and foremost, I'd like to show you guys the little bit of Toblerone which is left. So it's not much, but actually my wife ate it, not me. Yeah? So my tummy is still not so big. I have a talk about how we run a cloud native identity and access management system, which we actually built ourselves. And by which I mean Citadel. And also I will talk a little bit about the tooling which is involved. So the agenda for today, I guess, is a little bit about chaos because we're kind of a new kid at the block from eastern part of Switzerland, the lovely town in St. Gallen. Then I will show you a little bit of Citadel, but it's not a sales talk, so we will just scratch the surface of it. And then I will actually explain how our vision from we should run an application looks like and what we learned along the way, and then the future of all of it. So Chaos is founded in 2019. It's kind of a carve out of an existing company. We took the 10 employees at time, which are all specialized in the identity and access management field or in the DevOps and GitOps world. Actually, the company is totally owned by ourselves, so which is kind of great because we can make our own decisions in that regard. Everything we do is open source and with a great license Apache 2. I guess you all know that, so you can use everything I'm talking about today. We're with the Swiss-made software and we're committed to the OpenID Foundation, a sponsor as well, which is kind of a standardization premium for identity standards. Actually, our people look like that. You see, we have a giraffe there, which is actually the placeholder for people who had no time to get their pictures done. Otherwise, they would have been photographed with a lovely picture there. And the giraffe is actually our mascot. We have kind of a big one in our office in St. Gallen, which you can't use at these times, but hey, we have a giraffe. So what do? We develop 2 open source projects primarily. One is Citadel, we'll see a little bit of it today. And the other one is called Orbos, which actually kind of a software who runs a platform for ourselves with let's say a hardcore GitOps approach. So, and what we intend to do is we would like to offer one of the only really cloud-based identity as a service systems in Switzerland with our domain citadel.ch. We have a free tier, and right now we're kind of in an early access phase, so you can try it out. In the end, Citadel feels a little bit like a Keycloak, but I can tell you it's built a little bit different because you will see the technology stack we use is more cloud native. And that's clear because we had a greenfield project, and so we don't have many legacy parts involved. The other 2 positions are not so relevant for you guys, but in the end, we operate our services as well. So we have kind of support model for our customers, and we provide consulting to them in both fields, in the identity and access management field as well as DevOps. So Citadel will be consistent of a lot of buzzwords because, as we all know, what is IT without buzzwords? And so you will need to go through all those buzzwords for now. So, but bear with me, it will not be long. So what makes Citadel special? It has a cloud native architecture to it, which, hopefully when I'm talking at the Cloud Native Meetup. It has a low footprint, so it's not a Java monolith, but instead a small 60 meg Go application, which contains everything of the application, including the management GUIs and stuff. It is API first because the identity and access management system gives you everything you need to configure by API. And you can easily scale it from one server to multiple data centers, which is kind of a big thing in the identity world because you need to be available all the times. Otherwise, the blast radius in a system will be big. We support modern protocols. I think most of you guys will know OpenID Connect and OAuth, so I will not talk about those. And we have kind of a special dogma. we think of security features should be default and not hidden behind a paywall. So we look a little bit at Okta and Azure AD at that point, because you always need to pay something for features like 2FA and passwordless. And we think that should be free, these features, because otherwise you will end up with bad security, which is kind of an anti-pattern in the identity world. Well, we set off with those goals actually for Citadel. So it needs to be cloud provider agnostic, / multi-cloud, which is a buzzword as well. But in the end, we want to run Citadel in multiple data centers with multiple cloud providers to reduce the impact radius if something fails. We want to have as much as control as feasible, because in the end, we are a security system and we don't like to share our hashed passwords and secrets and stuff with other guys. Even if cloud providers say they're secure, we try to trust them as least as possible. We need our systems to be reproducible and idempotent, but in the end, idempotent is a great buzzword, but nobody understands it. So we will come back to that word in a little. Then we'd like to think of clusters as cattle, but that's nothing new. I guess a lot of people have heard that. But if a cluster fails from Citadel, we just simply replace it and let the database handle the replication of it. One of our non-functional goals was also to get a Citadel cluster up and running in about 15 minutes, which includes the infrastructure and the orchestration layers and stuff below the application. So we would like to deploy a cluster with any provider in about 15 minutes, which we're not far away of. Right now we're about 22 minutes, but we're going in the right direction, and most of the time we lose is from things we wait at the infrastructure provider side. And we would like to have everything auditable, because identity system needs to be auditable, and it's important for us not to have kind of a tooling hell. So with Kubernetes you can do mostly anything, but in the end you get a big pile of tools, and we would like to reduce that, because it helps us reproduce things. So it's really a compact setup at that point. So our architecture wall looks like this. If to give you some insights, the pink layer at the top is basically Cloudflare. We use Cloudflare for the CDN part, DNS, and global load balancing as well. Below we have kind of our clusters. Right now we have only the region CH available, but we will expand to the European Union at some point. We will see that on the future outlook. And we deploy clusters to data centers, and they're all fabric together by the database. So each cluster itself is now an autark unit which can fail without impacting the whole system. So as database, we utilize CockroachDB. We have a great relationship with those guys, and it really helped us to stay available in most cases. But as things show, we had an outage today for 12 minutes because with Google was something strange happening today. But Murphy is always there to help you see the failures in the distributed system. So I can quickly show you Citadel, but I don't want to stick too much to it. In the end, it's kind of a login system. I can show you the login with a passwordless flow. That's a WebAuthn, which uses my fingerprint to authenticate me against Citadel. And that's basically it. We have kind of organizations and stuff and projects, but let's not dive too deep. Let's just say you can do basically anything that the Keycloak could, but without SAML right now, because we don't like SAML at all. But anyhow, some customers would like to have it. So to go back to the presentation, which is not full screen anymore, which is kind of odd. Okay, it is now again. We come to the more important part, which should interest you guys, is how we run Citadel. And to keep it short, I have a video to start. I guess you know already DevOps Simpsons, and it's great because they pick up a fine thing today. Let me pause it here because you need to really embrace that sentence for a while. So it's just not possible to run an identity system with S3 storage, but keep things simple will oftentimes get you through dark times. So yeah, so we run Citadel with a hardcore Git approach, we would say, because we declare everything. Like, I mean, everything from the domain names through load balancers, and that posed some challenges for us. And we needed to some way to deploy clusters with Kubernetes inside without having any cluster to it. So in a normal setup, it looks basically like this, but I guess most of you guys already know a GitOps flow, so I don't like to talk about that too much. In the end, it's just we push an image to a registry. At some point, we decide to deploy it. We change something in a Git repository, which gets picked up by an operator on the down right side, and the operator will either change something in the Kubernetes API or will change something at the infrastructure provider side. And that's where things get interesting, because we also deploy our infrastructure parts with a GitOps approach. And that's the thing we call RBOS. RBOS is actually an operator. You can think of an operator in Kubernetes, meaning it's just a Go binary which manages our infrastructure, the orchestration layer, and as well the tools. And if we compare it to a thing like Ansible, it's more of a reconciling approach, as it iterates all the things at least once a minute to make sure that the state we declared, like I want to have a cluster with a certain amount of nodes, it will make sure each 60 seconds that that state is actually ensured. And so this gives us a really high release cadence, because we are absolutely certain that each cluster has the same state, and we easily can deploy a new cluster because we are sure that it looks the same. And this enables us as well to deploy Citadel in kind of a hyper-converged setting, where we can say, dear customer, tell us in which cloud you want to run Citadel, and we will bring everything with us to run Citadel, which gives it kind of a black box approach. But it's great to reproduce what we want to reach there, a managed service in the end. So, and what's so special about RBOS in the end is it is self-driving. So if you would compare it to a rancher or something, there is no classic management server in our system. So it's just a binary which runs in the cluster itself. So it's kind of self-driving. That was heavily influenced by the things the guys from CoreOS designed with Tectonic years ago, because it was kind of a self-driving cluster, and all you needed to do is to bootstrap it. And I will talk about that in a minute. So a typical Citadel cluster looks like this. The operating user will interface with the Git repository most of the times. And we have kind of three operating components involved in this. On the lowest level, we have Orbiter, which is a component from the project RBOS. It actually manages the infrastructure side. So it instances node, it configures load balancers, it configures firewalls. It's doing the IaaS job in that game. And after the infrastructure is ready, it will set up Kubernetes for us, and we'll make sure that each node has its specific role and is ready to get workload to it, and it updates the kubelets and all that stuff. But it's basically an automation wrapper built around kubeadm and the cloud provider APIs. Then we have the project Boom, the part Boom of it, which is a declarative approach to deploy a certain set of tools to a cluster. You can think of it as it makes sure that we have a Grafana deployed, that we have an ambassador as ingress gateway, make sure that we have Prometheus and all that stuff. and the value proposition of it is you just need to declare what you want to have, and all the glue code stuff that makes sure that these tools all operate with each other is actually built into Boom. So it is not like an absolute white box, a white base approx where you can configure all that stuff to a dev end. So it gives you more of a closet which you can choose what you want, what you don't want. And it is really enabling Citadel to run at any infrastructure, because at the end, the Citadel operator, which runs on top of that specific cluster, is just there to make sure that Citadel runs and that the Cockroach DB runs, because we need to manage the database as well with things like scaling and backup and stuff. And so we have kind of that approach where we manage our infrastructure, get the cluster up and running, which can serve any workload, not just Citadel. So those projects are not too tightly coupled at that point, because some guys want to be able to run Citadel at their own Kubernetes clusters. So we need to make sure that these clusters are not, these operators are not tied together too much. So a typical cluster looks like that. And we manage basically all resources like infrastructure, the platform, domain names, cloud LBs, Citadel, and the database. And that's all managed by a Git repository. And I don't want to throw too many YAMLs at you, but it might give you a hint of how our repositories look like. So we have kind of a repository. You see, we have a Boom YAML, we have kind of an Orbiter YAML, a Citadel YAML and stuff. And just to give you a peek, it looks like this. You basically declare how your cluster looks like. For example, you have a control plane with one node. It's called management. And down below, you define all the Kubernetes things like what's the cluster DNS, what network is used, service side or port side, or all that stuff. You don't need to run all the commands on your own. Just pump it in here, and it will make sure that this state is actually enforced on the servers as well. And you have here the provider abstraction. In this case, it's a GCE cloud. We don't use GKE because the vendor lock-in would be too tight in certain scenarios, like if you have identity for the workload. That really has a gap between all the cloud providers, and we didn't want to stick to them too much. So you define basically how your infrastructure look like. You also define how Citadel looks like with things like node selectors and stuff. And you can think of it as a CRD. So it's nothing else, but just located in a Git repository. So all our operator components directly communicate with the Git repository instead of going through the Kubernetes API. And we will see at the end why we chose that, because it felt more natural to us. And in certain scenarios, you don't have the Kubernetes API available. Like when you get the cluster running first, you don't have Kubernetes, so you can't store things in Kubernetes. So that's the trick we did there. So if we want to run the new cluster, what we basically do is regenerate the repository with the desired state files. That's a thing which is right now a little bit tedious because we need to cram the YAMLs together, but we will improve that in the near future with like an initial config which is written to the Git repository automatically. We generate an orb file, and the orb file is kind of special because you can think of it as the kube config for orbos, because it's a file which is written, which Git repository is usable right now. It includes the private key for SSH connection, and it also includes a symmetric encryption key for the secrets. So if somebody has the orb file, he can interface with all the things in the cluster, and we will see that in a minute. And if all the files are ready and the orb file is written, we just simply execute an orbctl takeoff, which will read the Git repository and will apply everything that's written in that Git repository. And actually, from there on, it's watch and wait. So, but to go a little bit more into details, we use a local CLI, which is called opctl, which is actually doing the heavy lifting if you start it locally. And it's just you write opctl takeoff, and then it will start kind of the RBOS process on your PC locally and ensure that the infrastructure is ready, the Kubernetes is ready. Then it will deploy itself to the cluster. So it gets kind of self-driving from that point on, and it will deploy all the tools necessary to run workload onto the cluster. And after that, if the cluster is ready, it will install Citadel as well. So you have kind of one thing, and you can easily ramp up the whole IAM in a minute. So, because I had a really bad day today with things like who broke, for example, my mic broke, our production broke, so I was not too keen to show an interactive demo at that point anymore, but I made sure we have kind of a screen capture of it. Hopefully it's big enough. Otherwise, the video will be integrated in the presentation. You can look it afterwards. It's just 55 seconds long because I really reduced the time to it. So normally it takes about 22 minutes. So I reduced it to 55 seconds. But what you basically see is all files are ready, and below on the lower third, the command is opctl takeoff, and you will see how RBOS will start ensuring all the things necessary. And right now, for example, it is creating all the firewall rules. It will create the cloud router, the NAT gateway, the outbound. It will create the instances. It will format the disks, because we sometimes use local SSDs with Google. It will make sure that the Nginx is installed. It will make sure the firewall is desired, because we leave even the firewall D on, even if Kubernetes default would be off, but we think of it as too much attack surface for that point. And it iterates through the desired state as many times as it needs to make sure the state is ready. So you see there is instance added to target pool. So one of the instances is ready, and you see right now the cluster is initialized, and after that the Orbiter will deploy itself to the cluster. So you see there deployed Orbiter takes over control, and it will end up there, and your local process will be terminated at that point, but you can read the secret from the cluster, which gets written back into the Git repository. So you have the kube config from that freshly started cluster in your Git repository, and you can read that from the repository. I will show you that because it's kind of a fancy feature. And we can show that that should be big enough. I'm quite sure of it. So we can not exact. We have some commands for the opctl. So it's always opctl -f. Then that's the op file for a specific environment. And then I have a helpful command. In that case, I want to read a secret from it. So I will do that thing on a live stream that shouldn't be done, reading a secret in public. So that's always fine. If I'm trying to read the secret, it will break. So as always, the demo gods are not happy with me. I have it recorded here. For example, we will say opctl read secret, and it will read the secret you define. For example, you can select the secret here, and then it's orbit, okay, there's kube config, and you will get the master kube config, which is encrypted and located into the Git repository. So you can easily use your cluster afterwards. But it does not stop here with the opctl. The opctl can also do things like, hopefully this one works, because at least I could test it. It can list you the nodes you have available in the at a certain provider you're working with. You can issue things like interactive commands. So I can do like the node exec -- command, and let's see how many free memory a certain node have. And I will get an interactive prompt, which is feasible by connecting from a local G-Cloud utility in the background through the identity proxy at Google onto the machine, which then gets the command on the node, and you get the result back. That will take some time because the G-Cloud is quite slow at sometimes. And hopefully it does not break as well. Otherwise, I have a really, really bad day and everything breaks. So, okay, now we have it. So you see, from a certain node, we get the result back. That works as well for things like replacing nodes and scaling, and all the stuff basically goes either through the obctl or through the Git repository, which includes all the data that is necessary. So we just simply run our clusters like that. No, next slide, please. What did we learn? The full screen mode does not want to stick with me today. So what did we learn about all the things we do with our tooling? It basically boils down to these bullet points. So we should like choose the users, what if they want to use a sole GitOps approach, or if they want to use K8s storage for Citadel, by which I mean if they want to utilize a normal CRD process or go with our GitOps strategy. Both options are can be used. In the next release of the Citadel operator, there will be a CRD option, and this will also include things like managing the identity and access management systems resources by CRD. And yeah, we should really provide a more UX-oriented way to install all those things. With obctl, we have already done that from our perspective, but with the Citadel operator, we'd like to go in more or less the same direction as, for example, Linkerd goes, because they really provide a great user experience for installing Linkerd into a cluster with just Linkerd install or Linkerd --HA install, and we will go more or less the same strategy there. Then we merged Orbiter and Boom into one project, which is today called Orbos, but these projects were separated at the beginning because we thought of, let's have a thing that manages infrastructure, let's have a thing that manages the platform. But in the end, it boiled down to, hey, we need to have something that creates platforms and not Kubernetes clusters, because Kubernetes is just an enabler for us. It's not our holy grail in the middle of the world. Then we needed to split the Citadel operator logic from Orbos, because in the beginning it was located within Orbos, and we soon saw that will not scale great. So we are right now in the process of removing that so that Citadel gets its own operator, which comes down to the UX for the installation. We had some really funny effects with Google's local SSDs. Maybe other guys have seen that problem as well. So we experienced really high I/O weights with CockroachDB on local SSDs, and we found out that disable the write cache flushing was just the nifty little detail we needed to respect to get great performance, which meant just edit the etcf step file with a no barrier command when you mount the disk. And it's actually no problem for us because Cockroach operates with a quorum concept. And so if two nodes write something, you can expect that at least one disk will receive it in the end. Otherwise, you have transactional problems as well. And one thing that hurdles us a little bit as of today still is the east-west connections across providers are no easy task. That's a thing we're really trying to experiment a lot, because you can either go the service mesh route or you can choose the VPN HDS approach between cloud providers, or you can go each node has a public IP approach, but in the end, you need to make sure that your database can connect overall cloud providers away with a kind of a meshed approach, because that's how CockroachDB operates itself. But it's just a nifty thing, a detail which needs to be addressed. And we're right now playing around with Linkerd for their position, but right now we're sticking to public IPs and the zero trust approach, because the database talks to itself with MTLS. So the threat involved is not that high. And we can apply firewall rules as well to that IPs. So I thought I needed to pick up some time, and I guess I'm good in time right now. And let's talk a little bit about the future. And that's our future as we plan it. So the general availability of Citadel will be around Q1. So right now, more or less. So end of this Q, we will have a shippable product. Also with the Citadel operator ready with CRD support, so you can easily install Citadel into your environment as you choose. In Q2, we'll see things like webhooks, because we think of an integration pattern for an identity system. Webhook is a great thing to do. We will also improve our audit GUI, because Citadel is event sourced. We can really do much with auditing, but we don't leverage that too much right now because we're in a GA phase. We will expand Citadel to more regions as we go. And one thing that struck us as interesting position is, should someone synchronize roles and cluster role bindings and stuff with the identity system? So we will kind of test out how K8s adapter for Citadel will play out. So it's more or less a proof of concept, but we think of it that it will be established soon. And around Q4, I will say much, because it's just unplannable at these times. Otherwise, we need to flow with the flow, because Corona times are strange. So we will see where we're going with that. We have a lot of ideas, but they need to be scheduled right away to really get it rolling. So that's more or less the real quick thing about how we run Citadel with GitOps. And if you have any questions in regard to how our tooling functions, or how our vision is around that, feel free to contact us either by Twitter, by mail, or by GitHub, or anything you would like to contact us. And if you need in the next time an identity system, feel free to try at least Citadel, or give us a call. We really try to help there. And the one and only thing sales-wise I will really tell you guys is, Citadel will not have a licensing model revolving around users, because we find that kind of an anti-pattern for an identity system that you need to pay by user. That's more or less it. I hope you enjoyed. I'm open to questions right now, and don't hold back. Ask any questions you would like to ask. I will try to address them as thoroughly as I can from the top of my head. Thank you.
Okay, merci vielmals, Florian. Johann, gibt es Fragen aus der Community?
Yeah, we have a couple of questions. The first one is, don't you have some sort of a chicken and egg problem when managing IaaS within IaaS?
I don't really grip the questions, because we don't really manage IaaS within IaaS. So the process normally is, you locally use the ops ETL, and then the IaaS part gets bootstrapped at any provider you like to choose. Right now, for example, we support integration through SSH for any node, basically, or you can use Google, or you can use CloudScale. And we will instance the nodes and everything with that cloud provider. And afterwards, after these nodes are running, and then the platform is running on top, we will instance the managing component on top of that. So the chicken and egg problem is more or less just available when you're trying to instance that without running on top of it. But maybe I'm wrong, but we haven't had any problems with that kind of approach.
Okay, thank you. There's another question about do you support other cloud providers?
Yes, so right now, any node that can talk SSH, so you can use any bare metal or VM you'd like to. Otherwise, we support GCE with automated bootstrapping of the infrastructure parts, and also CloudScale, the Swiss provider, because we have certain customers who would like to run the workload in Switzerland, and so we support CloudScale as well. And all of them can use a declarative approach, so you can really declare, hey, I want to have 5 nodes with CloudScale with that node profile, and go for it. So you can bootstrap an Orbos cluster with CloudScale in about 15 minutes with all the firewall things in place and stuff.
Okay, thanks. Is it also possible to run it on premises?
Yeah.
You've already answered that question, but I personally missed it.
Yeah, we have actually a customer who's running around 20 clusters in its own data center as virtual machines. And we have another customer who integrates Orbos into its own IaaS offering because he wants to offer kind of a vanilla Kubernetes to its users. So the automation part comes from us. So you're really free where you want to set up Orbos at that point. So if your node talks SSH, you can use it.
Yeah, and then I have a personal last question. Well, it's not a personal one. I cheated a bit. I asked you what the most asked question is, and you told me, yeah, it's why did you write it by yourselves? So what's the reason for that one?
Basically, it boils down to we wanted to have a GitOps approach even for the infrastructure with a reconciling behavior without running a central management system to it. So we wanted the whole system as one combined unit. So each cluster runs on its own, and if something happens, it will break one cluster, but that's not the problem for us in the end because we can run multiple clusters. And that boils down to the idea we recommend our customers in certain scenarios to design the Kubernetes world, not in one big fancy OpenShift cluster, but instead go with a domain-driven approach and try to form little autark units which can run on their own. So if something breaks, your blast radius will not be too big. Because we have seen a lot of big clusters fail under certain scenarios with hideous little things. And it's just our vision of things. It's not the absolute truth. But we think of it like that. And Rancher and all those tools didn't offer us any of those all of those checkboxes. So we ended up building something for ourselves for that exact reason, the reconciling and GitOps reason mostly.
Thank you very much, Florian. I'm handing over to Philipp now.
Merci vielmals euch beiden. Florian, kannst du noch den Bildschirm wieder, dass wir alle sehen?
Yes.
Genau. Merci vielmals, Florian, für die Ostunterstützung für die Region Bern. Gell? Und ja, wir sind am Schluss. Eben, was ich noch sagen wollte, weil ich vorher fast schnell war, 18. März wäre das nächste Meetup, wo wir uns wieder sehen. Virtuell.
Ja, jetzt ist irgendwie der Ton von meinem Kollegen ausgefallen. Also am 18. März wäre das nächste Meetup. Ich weiß nicht, was ich sonst noch sagen wollte. Ich kann ihn nicht gerade so...
Wieder zurück. Okay, sorry, ja,
super.
Ich will sagen, ja, ist immer noch instabil. Ja, 18. März, das letzte Mal, und wir würden jetzt Tschüss sagen. Winken, winken.